Okay, now we are going to discuss about the air compressor test rig. Uh, Air compressor test rig. Here you can see that this is the two-cylinder engine. One is the low pressure cylinder and this one is the high pressure cylinder. In between we can see that a intercooler. This intercooler increases the efficiency of the air compressor. For the low pressure cylinder, this is the gauge to measure the pressure in the low pressure cylinder, and this is the second pressure gauge is used to measure the pressure in the high pressure cylinder. Later, this is the YouTube manometer to measure the airflow. The temperature indicator is there to measure the different temperatures before entering to the low pressure, after exit from the low pressure cylinder, in between the intercoolers, and after exiting from the high pressure cylinder. And the compressor speed is also noted from this dial. And the bottom you can see the air duct is there. Air duct is there to measure the airflow, to measure the airflow to the air compressor. Now we will start the experiment and we will going to note down the readings of low pressure cylinder reading, high pressure cylinder reading, and YouTube manometer, the difference between the difference of level in the YouTube manometer, temperature indicator at different points. Later we'll go and the different speed, and also how much of the energy consumed from the energy meter disc. Here the experiment is conducted for different condition, means 0 to 5 is there, 0 to 5 is there, 1, 2, 3, 4, 5. We will going to conduct the experiment in between 0 to 10. We are not going after the 10 for the safety purpose. Hello. Reciprocating air compressor, the experimental part is over. Now we are going to discuss about what the calculation part. See, the following observation you should be note down. That is what diameter of the RIT is. Then once you know the diameter, then you find out the area. Next, diameter of the low pressure cylinder D1, diameter of the high pressure cylinder D2. Once you know the D1, D2, calculate the A1 and A2 also. Area of the low pressure cylinder and area of the high pressure cylinder. Stroke length, note on it. Energy meter constant, that should be note on from the energy meter disk. Efficiency of the motor is taken as a 75%. Coefficient of the discharge of the RFI is taken as a 0.65. Density of air is 1.293 kg per meter cube. Number of revolutions by the energy meter disk, you take it as the 5 for this experiment. Once you calculate all the observation, and this is the tabular column. In this tabular column, during the experiment, we have to go into note down this value, delivery pressure, pressure after the stage 1, stage 2, and airflow across. And it means YouTube manometer. What is the difference head is there, that should be calculated, and this is you have to use the formula. Next, energy meter reading for the 5 rotation, how much of the time is taken. Next, speed, this is should be noted from the experiment, and the temperature is also noted from the temperature indicator panel, temperature panel. Okay, these are the things that should be noted on during the experiment. Remaining thing is the calculation part. First, we have to find out, we're going to first head we have to find out what is the final pressure you obtain. You have to multiply by 7734 to convert into the meter, and the actual discharge that should be calculated. This HA should be calculated using this formula, HW divided by 100 into density of water divided by density of air minus 1. Isn't that why you get the airflow in terms of meter? Using this HA, we can calculate the discharge. Once you calculate the H as well as the discharge, head as well as the discharge, we can calculate the output power. rho g QH divided by 1000. QH is calculated using these two equations. We know the density of the air is 1.293 already. That is observation. G is the acceleration due to gravity. By using that one, you can calculate the output power. Next is the input power. K is the five rotation. Time is the time taken for the 5 rotation of the energy meter disk. And this is the constant available in the energy meter disk. So easily you can calculate the input power also. The ratio of output power divided by input power will get the efficiency of the compressor. Once you find out the efficiency, the total swept volume is very simple. That is the Vs1 plus Vs2, area of the first cylinder into stroke plus area of the second cylinder into stroke. You will get the total swept volume. Actual swept volume means the discharge into 60 divided by speed. And if you take the ratio of actual swept volume divided by the theoretical swept volume, you will get the volumetric efficiency. So this is the calibration part of the air compressor. Thank you.